Oh, record on this computer. Let's see what that does. All right. Well, I think we can probably get rolling. There's 21 people in right now. If anybody has questions, feel free to jump in. I don't think it's going to be a really long lunch and learn. Really, this is basically a refresher course for some of the tools that I see as being underutilized, and then some of the tools that I think a lot of people who may have been using ArchiCAD now for quite a while, may have been at Walker Warner for quite a while, but are just starting to get into new projects and needing some of the sort of what I call the more advanced tools, and haven't needed them up until this point. So I just want to kind of make sure everybody's on the same page and realizes that these tools are accessible, usable, and that we all know how to use them. I want to start off with one in particular, the curtain wall tool. This is one that we in the past have kind of avoided because it's really cumbersome, it's clunky, but for Bar BC and actually for PB Ranch as well, it's proven to be pretty useful. I've actually copied over Matt's curtain wall here, but he's used it basically instead of having a wall, and I don't even know how many windows this would be, 100 plus windows and several exterior doors. There's, I think, like probably 5 or 6 curtain walls in this project that represents all of those fenestrations combined. So the curtain wall tool can be a very user-friendly way to model something like this condition. And I know that this isn't the only project that we have sort of a structural design like this, where essentially it is designed like a curtain wall, you know, with the structure offset in and then the actual glazing panels offset out with their own non-structural frame. So really that's what the tool is made for. Setting the curtain wall up is actually fairly straightforward once you've gone through it. It's not necessarily what I would say in the best order, the organization of these subpanels here. Basically, the whole curtain wall system is going to say this is how tall it is. That's going to define at what height does that pattern that we set up in the scheme setting here start to repeat itself. So where it seems backwards to me is under the frames and the panel section. These should really be set up before you go into the scheme settings. In this case, it's pretty simple. We just have panel A, panel B, panel C. And really, it's just like an ABA pattern here. And then the in between pieces, these dividers are mullion frames. Those also have a definition. What is that frame? So each of the boundary frames and the divider frames are set up here. So you can define what the corners are, what the boundary frames are, and then you can create any number of additional frame types here. These can be custom profiles. They can be some of these stock shapes that ArchiCAD provides for us, or you can turn them off altogether. And then the same thing with the panels. You can have any number of panels. And these could even be custom panels. In the case of, actually, Matt and I were talking earlier this morning about how you'd have a single panel that actually had like a lower awning and then a fixed upper piece. Really, there's no straightforward way to do that, because if you in the scheme you insert a window type, for example, curtain wall sliding window, casement window. Obviously, the options here for operations are not quite as diverse or wide-reaching as with the CAD image doors and windows, or even the ArchiCAD doors and windows. But for a curtain wall system, it's probably going to be pretty close. But we can also create a custom panel, and that's what I've done up here on this sample. I copied this over here. So you can see here that there's different panel widths and different mullion locations. But what I did is I just modeled using slabs similar to, or really identical to how you would model a custom door leaf. So I've modeled this lower awning sash, a horizontal divider, and then a glass piece up above. You just select that stuff and go to File, Libraries and Objects, Save Selection as Curtain Wall. And you can create custom curtain wall panels, leaves, frames, caps. There's different curtain wall components here that you can actually create and save as. And that's what I've done here on this piece. So if we look at this, that gets applied to this curtain wall panel here. If I wanted to apply that to additional curtain wall panels, I can select the curtain wall as a whole. I can say edit that curtain wall, and I can just grab and hold shift all of the panels that I want to adjust and apply that custom leaf to. Instead of saying that this is a built-in curtain wall panel, I would just say that this is a custom panel, and then just like with the custom doors, I get a whole drop down of all custom curtain wall panels that have been created for the project. Now these are not necessarily operational the way that you would see an awning, but in elevation and in 3D, it looks the way that we need it to look.
And I'll just quickly add that in the curtain wall edit tool that Pat was just in, it's possible you can draw custom frames, custom mullions, you can add custom conditions. You could make that big panel a cased opening without breaking your pattern. So it's pretty flexible, especially even for us when I was in like the early SD stages of designing this out and doing design options every day of different patterns. You don't have to go through the full steps of creating a defined system for it. You can custom model that and change it on the fly. So I liked that part of the curtain wall as well. So something to consider when you're doing early SD modeling.
Yeah, you can grab, like Matt was saying, you can grab pieces, you can drag copies of them, create other divisions. You can, in this edit function, you select the curtain wall, you go to edit mode. It's this little edit option right there. You can grab like an individual mullion and move it, you can delete it. We actually used this at one point in PB Ranch instead of using the CAD image covering tool, because it allowed us to basically have these reveal joints on a panel siding and move those and shift them and kind of more freely design the siding pattern rather than using some prescribed pattern width for those panels. So it's a pretty flexible, versatile tool. It can be tedious, but I think that the benefits definitely outweigh that tedium in that you have fewer elements to manage. The whole thing is just drawn in as one. Once you get the system set up, you literally just draw it in. You can draw in multiple edges, multiple nodes, all in one panel. And it's pretty flexible, pretty editable. The other thing about it is, as opposed to the door and window tool where individual doors and windows are annotated automatically, we actually have to label these curtain wall components individually, and we have to schedule them differently. But to label them, you just take the label tool. If you hover over the curtain wall and you hit tab, it will actually apply a label just to that curtain wall panel. And just like we saw before with the edit function, I can grab just that panel. And in the settings of it, I could say that this is panel 1 or whatever the ID of that needs to be. And then that label ties directly to it. So that's the first tool I wanted to present, something we've been using quite a bit this year that we've basically avoided in the past. Moving along, I want to pull up the template. I've kind of set up some other tools that have come up recently, tools that everybody should know and be comfortable with. First, I want to look at the Morph tool. The Morph tool is one that we use almost exclusively for cabinets. The main thing I wanted to point out with the Morph tool is what we should and shouldn't be using it for. It should not be used for primary building elements. It shouldn't be used for coverings, for decking, for walls, beams, columns. There are better tools for those elements than the Morph tool. But the Morph tool does work really well with sort of more organic shapes and complex things like cabinets. There's some really cool tips and tricks that I just want to kind of run through here really quickly with the Morph tool. First of all, you can draw morphs in, and we actually did this on Arthur Washington. I'm sorry I don't have all these files up. It was quicker and easier just to demonstrate this in a blank file than to cycle through 10 or 15 projects that use all these different functions and features. But if you, in Arthur Washington, we had these sort of convex compound curve arcs. And you can draw those in with the Morph. And then if you go to Design and Modify Morph, there's this Cover with Faces option. So you can define that face as part of that arc. And because it is a Morph, you can actually rotate it in all planes and all axes. So you have the option to kind of freely manipulate, navigate, or organize these morphs, which worked really well at one point for the sort of pool arcs in Arthur Washington to develop these kind of compound curves. The other thing that I like to do frequently when you're looking at the morph tool as a sculptural thing, if you have a void, and this is something that we've done with like cast in place sinks on counters, for example. Like I said, this tool is almost exclusively used for cabinetry. So if it's like a cast in sink, you can basically take a ellipsoid or a sphere from the object tool, convert that to a morph. And if you use solid element operations, this would be your operator. This piece is your target. I'm signed out. We're still online, right?
Yeah, I can hear you.
Okay,
Yep.
So that's weird. Zoom just gave me a message that I was signed out. Somebody else signed in. I don't know. Okay. So this is the target subtraction. We're going to execute. And you could see that it's already sculpted that thing out. But with solid element operations, this piece is dependent on that piece. So if I want that shape to actually get cast into this morph, as you might with a cast in place sink, for example, you can convert this morph to a morph. And at that point, it retains the shape of that SEO without having the SEO. So that's a pretty neat way to kind of get more sculptural and kind of get some more organic forms into a morph, basically carving things away with that basic shape library. The next thing that I wanted to point out is the solidity of a morph. And this is important for a couple of reasons. First, if you do any solid element operations on a non-solid morph, it's going to basically show with a void. It won't fill in that face like we saw with that previous example. So SEOs don't work on non-solid morphs because essentially they're just hollow. They can't create or generate new faces. Next, it is you don't get cut fills with a non-solid morph. So non-solid morphs can be several things. This morph seems solid, but it has this extra little line there. If I go to check solidity, it's going to say that this is not solid. I can try to solidify. This one's not going to be able to solidify because it doesn't know what to do with this extra little leg there. And this is one reason that it's not always the best thing to start with a morph and start carving things away on really complicated cabinets. A lot of times I'll actually build the cabinet up out of individual slabs, beams, columns, walls, and then convert those to morphs and Boolean them together. But something like that where it's just a little leg of something sticking out, if you could track that down and then check solidity, we should be solid now. If it's something really simple like this one, it's just a face missing, I can check solidity and solidify, and it should solidify that one. But working from a morph from the beginning, as long as it's a really simple, basic shape, is usually okay. It's usually when you start like grabbing individual edges and copying those down and pushing and pulling and getting those sort of micro reveals that you start ending up with non-solid morphs. And it can be something as simple as like what we saw there with just a little line that didn't get copied, or a fragment of something that's on there. And tracking down all those little details that need to get purged is really tedious.
Hey, Pat, I got a dumb question kind of related to that. So a lot of the times if I'm like initially starting out doing very early on cabinet modeling and I accidentally drag one point and it causes, let's see, I don't know if I can draw, but it causes like a diagonal line across the face of a morph. Are we easily able to delete those like how you just did with your little morph, the half segment there?
If I understand it, like it's stuff like this, right, where it ends up bisecting.
And yeah, go ahead.
If it's because something's not quite in line, yeah, you can delete that. And the easiest way I've found to do that is actually in the pet palette here. You can grab that node and pull that over.
Got it.
Yeah, you can technically hold Control-Shift. You can grab that and delete it. But if it is actually a case of this being up like that, and sometimes it's hard to tell that that's what's going on, right? If it's just off by like a 64th of an inch, it's not going to be able
Got
to
it.
those with faces. So deleting that will get rid of it. And if I drag this to here, like I did before with that up, it's going to bisect the other way. So that's sort of an indicator that something's not quite flush, not quite in line.
Got it.
Sometimes what I've done is basically take it and split it off of like a known vector, delete it and recover with faces, or in this case, it actually managed to cover it with the face automatically, maintain the solidity. So yeah, that's something that can be a little bit tricky to track down when you've got those edges. The other thing about the morph is a lot of times, you end up with stuff like this and you go, oh, well, I want to get rid of these two pieces. And sometimes deleting those will delete the whole morph. I don't have a good reason on why that does that, and it's a real pain to try and track that down. Again, the workaround for that is to basically grab these edges and just track them around and get rid of it this way, if you end up with segments that are deleting the whole morph.
Got it.
So yeah, the morph is not it's not a foolproof tool. It's kind of buggy and odd, and that's all the more reason that it's usually better to if you're modeling a cabinet, for example, to just model it with basic massing. We actually have beam profiles specifically to get cabinet massing in there, and then you get to the level of detail you want and you convert those to morphs, and then you can add extra detail after that.
Got it.
Okay.
Thanks.
Next feature of the morph is basically faces and segmentation. So this is a sphere that was converted to a morph. This is a lower resolution sphere that was converted to a morph. There are tools, and you can see like there's a sort of weird glitchy piece right here. Even though these were both converted from the same object, I just took the basic shape library. Where are we at? Special construction. Oh, this is the Walker-Warner library. Same library, just under the ArchiCAD library. Special construction and basic shapes. There's a whole collection of basic shapes that I like working with to do like plumbing fixtures. These elbow and tube features work really well. You can actually control the resolution of those elements. So you could see like, instead of getting those segments, you could bump this up to like 64 and you get a nice smoother curve. You don't necessarily have that control over the morph out of the gate. This is a morph disk basically that was drawn. You can go up to design, modify morph, and this modify segmentation feature. You can add or reduce segments basically, and you can see how that starts to increase the resolution. It doesn't always work. In this case, this was a basic shape set to I think like 5 or 6 on the resolution. If I went up to modify morph and modify segmentation, double the segmentation, yeah, it starts to kind of smooth out, but it also just looks really lumpy, like a dinosaur egg. It works a little bit nicer in the inverse direction. So if I went to modify morph and modify segmentation, if I went to fewer segments, I can reduce the polygons basically of a morph, which is actually really useful if you're saving morph elements as objects. Which is sort of its own can of worms that I do want to look at here in just a second when we talk about shells. So yeah, the morph tool is something everybody should know. Those are some features that I think make the morph a lot more useful. Something that just occurred to me, and something that we haven't been using the shell tool for, I want to kind of transition over to the shell tool now, is for site walls. Typically, we've used the wall tool or even the mesh tool for site walls. And if we look at that here, so I just magic wand this spline. And you can see here, using that wall tool, I end up with all of these wall segments. Some of them heal together and I don't get a line between them. Some of them I get that vertical line between. They don't always tile out very nicely on the surfaces, depending. And depending on the angle of the curve, sometimes you get some really gnarly, basically chamfers where those come together. So, and more than that, you just end up with all of these walls for one sort of organic wall shape. So I was watching a video and saw this really cool trick where if you take the shell tool and set it to an extruded shell with a custom shape, right? you can hover over and extrude that, and then we just say that this wall is, let's say, 10 feet tall. And then we get that shell here. The cool thing about this is it's all one element, right? The extrusion is centered up on there. So if it was a 10-foot tall wall, you might need to move it up or down. But even with the wall tool, half the time they end up half buried into the terrain. And then if you needed to adjust the height of this, you could, just like you would with the wall, do an SEO or something like that. So this seemed like a really cool trick for doing like some planter edges and things like that that might have more organic shapes to them, and get that continuous curve. And you can see that there's still those nodes there, but I don't get those vertical lines. They don't necessarily tile out all that great, and I was just noticing right before the presentation that this one for some reason changes the orientation of that surface, so it might be something that we explore a little bit deeper if this ends up being used in projects. But it was a tip that I picked up earlier this week that I thought might be good for everybody to just be aware of and maybe try out on your project site models if it becomes applicable. So that's shells versus walls. Another one with the shell that I really like, and again, it's something that I use for like custom light fixtures, custom plumbing fixtures and things like that, is the revolved shell. So the revolved shell is basically just that. It's a revolution of a shape. I just grabbed a random light fixture cut sheet, traced it out. You use the geometry method over here, revolved, and then custom shape here. And then you can just hold down space and magic wand that. It'll let me know. There we go. And you can revolve around 360. The other cool thing about this, just like the Morph tool, the shell tool is fully rotatable. So you can freely rotate these in space, X, Y, and Z axes. Also, that profile here is adjustable after it's been modeled as well. So I can grab the edges and adjust and extrude that profile around even after it's been generated. One of the biggest reasons that I actually really like the shell tool is for saving objects. So I wouldn't necessarily keep this light fixture as a shell. I might save it as an object. And I've done that here. And to compare that, I've also modeled this with a Morph. And there's really no discernible difference between the Morph and the shell generated content. The Morph is a lot more tedious. If I ever wanted to go through and adjust this Morph, it would be basically start from scratch for a revolved Morph, as opposed to the shell, which I have all of those profile edges that I can edit. But the biggest difference is when you save this as an object, the object sizes are drastically different. Saving the shell as an object is like a couple of kilobytes, because it's only like maybe the critical lines of script. It's maybe like 20 or 30 lines of script for that profile to turn that into a GDL object that can be placed into your model. The Morph, on the other hand, same exact shape, but generated from a Morph is, I didn't even scroll all the way to the bottom here, is 1,200 lines of script. Or more. No, it's got to be thousands of lines of script here. It's massive. And so the object size ends up being a lot bigger. You know, like it goes from kilobytes to several megabytes for the same exact object. So the shell tool save to objects is a lot more efficient. Okay, new tools. I know that we talked about these when ArchiCAD 23 first came out, but I just want everyone to be aware of these sort of more complex tools. The beams, columns, we already talked about the curtain walls, but I also want to try and talk about the railings and the stairs today as well. So the beams, I have a few examples of the new beam features and where those are useful. Typically, if we had a piece of baseboard, for example, we would have to model that with a custom profile just so we could get that reference line at the bottom. In the new beam tool, however, there is this option right here for the reference axis, where that axis sits, so that when you draw it out, if it's at 0 to home story and that reference axis is at the bottom, your baseboards are basically from the bottom up. So if this profile changes, it'll move up there and then that reference line stays stationary. So using just a basic square stock baseboard now, we don't have to have a custom profile for all of those conditions. You also don't have to have that offset. Previously, it was always center top of the beam, and now that offset option is actually able to position to any of the four corners, center points of those edges, or the center point of the beam. We also have options in the beam tool for end cuts. So if you have like rafters and things like that, the end cut of that beam can be custom now, which is super useful. Beams also have cover fills, which is something that's been a long-standing request. But under the floor plan and section, there's a cover fill option right here. So beams can actually mask things out in floor plan, which is super useful. Next, beams can have segments. And this one, ArchiCAD likes to showboat a lot of really complex beam and column conditions where they basically model huge moment frame structures with a single beam. It's really tedious and it's a waste of time. You can use 30 elements to model that moment frame and model it in probably 10 minutes, or you can try to do it out of a single beam and probably take 3 days to do it. The thing I like the segmentation for is the opportunities to model ductwork if we end up doing that modeling instead of our consultants. Fortunately, more and more of our consultants are doing the MEP modeling for us. But if we do end up doing the modeling, it's as simple as basically taking a single run of a beam, and you can add any number of segments to it. You can see the segments being highlighted here. Those segments can be a locked width, or they can be a flexible length that can be extruded with the beam length. In this case, basically, I have a reducer on this beam to go from a 2x2 duct to a 1x1 duct. And each one of these segments are set individually, as are the junctions between those. So again, because the end conditions are adjustable, if this beam were at an angle, you would have the option to adjust the joint condition of those different segments. And that's just right here. So you could say that those join at like 45 degrees if for some reason that needed to happen. The next thing about the beam tool that I honestly just noticed about 3 weeks ago is that, and this is one that we run into pretty regularly, right, where we have a bar drafter and we have a fascia. The bar drafter is sloping, the fascia is not. Typically, when these intersect, we get this nasty junction. But because the reference line is customizable now, we can basically say that these two things intersect, but they don't intersect at that point. The intersection node isn't consistent. So that allows us to have basically a vertical eave fascia and a sloping barge board that clean up without having to have separate non-intersecting layers, which was our solution in the past. So this is actually a really, really cool feature of the beam tool, that we can get these really basic trim conditions to clean up without jumping through layer intersection hoops. Okay, columns, same thing as beams. Just like we were looking at with that horizontal beam, here in the column, we have the same features in the column tool as the beam tool with the segmentation. So we could say we have a 2 foot tall reducer on this beam segment. The beam tool and the column tool are sort of just mimics of each other. They mirror each other. So we have the same reference axis points. We have rotation end conditions. Floor plan appearances are a little bit more flexible, but they always had a cover fill on those before. So the columns work really well for ductwork as well if we end up modeling those. Let's see, what else do we have? End conditions, we talked about that, but this is sort of an example of those end conditions where we can have a beam and a column that actually miter together now. And this is useful potentially for door and window trim, whereas before we had to have a solid element operation to get those to miter together if it was a complex profile. Now we could basically just say that these have a 45-degree joint that joins those two elements together. We can also see here that if this were ductwork, for example, offsetting that reference point of that column to the edge actually means that this flares out and is flush on one edge. So that could be something useful in terms of modeling either custom profiles or ductwork or any number of things. A few things on the PET palettes for these beams and columns. You'll notice that there's additional options here for things like sloping the end conditions of those beams and columns. Other than that, the PET palette's pretty similar. You know, the end column, the slope, the length, all of those are the same. But that rotate end condition, you can actually do that directly in 3D with the PET palette. So if it's something that's not necessarily at a 45-degree end, as this condition is, you can actually figure that out in 3D by snapping to references and using that PET palette option. Okay, the last thing to cover today is the stair and railing tool. I think everybody should be at least familiar with the stair tool right now. There's a couple of things, just like we looked at with the curtain wall tool. You do have the option to go into edit mode of the stair tool, and you can actually offset, extrude, chamfer. You can modify that stair. The one thing I will say about that is you want to make sure that in the stair settings, the structure and the height and the tread and riser settings are all dialed in before you do that. It sort of can screw things up if you try and modify the main stair settings after that edit function has been engaged. Another thing that has come up probably on every project that's used the stair tool for a non-straight run stair is how do you get this zero clearance at that corner? And there's a few things, and I always end up like chasing my stair around in circles to try and get it to work. But the first thing to do is to make sure that none of these rules and standards are checked. You know, we can make sure, a lot of that's just to make sure that the walking line code and basically you can input code standards for any number of things. And we can verify that code just by saying, oh, this is the rise, this is the run, and this is our landing clearances. We can do that kind of manually, and it gives us the option to be a little bit more flexible with the stair. But to get that zero clearance, the first thing you want to do is right here in the stair selection settings, you want to click this flyout and make sure that this is set to fixed riser offset, and both of those are set to 0. Now, sometimes that for some reason doesn't work, especially with like U-shaped stairs. You know, so if I had a stair that came up and then over and then back down, that riser clearance here might not zero out. And of course, it's not going to do it when I try and force it to here. But if it doesn't, you can always click on the corner here on the reference line corner. And this is the other place you want to make sure that that zero clearance is applied to the entire stair, and it's set to fixed offset and set that to 0. And if that's been done at the stair element and in the stair settings, it should force it to have that 0 clearance. Those are sort of the two big questions I see come up with regard to the stair, are that edit function and then modifying it after, and then the 0 landing. If anybody has any other thoughts or questions on the stair tool, feel free to chime in. My opinion on the stair tool hasn't changed in the last, I can't even count how long I've been using ArchiCAD now, 14, 15 years. It's basically been that the stair tool works great when good enough is your aim. If you have a specific stair design that you're trying to model, even now it's still usually easier and quicker to model it with slabs, roofs, beams, columns, any number of other things. Certainly the stair tool can work if it's something really simple like just this open riser, single stringer stair. ArchiCAD has designed a stair tool that does handle some of these conditions okay. But you know, like even something like this where the nosing needs to wrap around the edge, or you end up with these really weird goofy conditions right here where just no idea why that's showing up that way. If you really need to dial this stair in, it sort of needs to be modeled with slabs and beams to get this stair design exactly figured out. The other thing about that stair and the railing, if we isolate these out together, is that the railing, if you draw that in, right, so if I hover over this stair, it'll highlight the stair each one of these clicks is basically saying that railing is going to be associated with that stair, which makes the railing tool kind of a cool tool. So that if the stair changes, that railing should change with that stair. Again, though, the railing tool is kind of goofy and clunky. You get stuff like this all the time with the railing tool where it's just obviously that's not what we wanted. Even this is not what we wanted on that railing. So a lot of times with the railing tool, it ends up being just more efficient to model with beams and columns and an occasional morph or shell element. I think that's kind of it in terms of talking about these tools and these features. Does anybody have questions, comments, feedback?
I guess this is a manageable. I'll add that for stair modeling. It's something that I find myself doing is if I have to model stairs, at least at first, I might use the stair tool to help space out the risers and steps equally, and even add on the railings for how high that should be. But like Pat said, I always find myself eventually replacing that. But one good thing is if you let the stair tool do the math for you and you can get that to work out, it's a lot easier than trying to figure out the spacing on pen and paper. But you can go ahead and trace that with your slab tool to draw every single tread. But I totally agree with that. At some point, we're going to get into the level of detail that the stair tool isn't going to cut it for most all of our projects, I would say. So plan on at some point coming in and customizing it with slabs, some other tool.
Right. It's something like this where you're just like, oh yeah, I have a straight stair. Or I mean, it could even be something, I know on a couple of our projects, we've had like stairs that had these sort of flares to them. So you can do really cool stuff like this, and it works really well for like early schematic design, right? You could do stuff like this for SD level models. But when you start actually getting into the nitty gritty, the details of what that stair needs to look like, it's almost always just kind of going to fall apart, and you'll end up either tracing it out with slabs and modeling with slabs and roofs, or tossing it out completely and starting over. Anybody else? All right. Well, I guess if anybody has any follow-up questions about any of these tools, if you see a use for any of these tools, feel free to, as always, just hit me up, and we can always do other screen share sessions and go through this in more detail. Yeah, otherwise, I guess have a good afternoon.
Thanks, Pat.
Thanks, guys.
Thank you.